Our next topic is acceleration. So let's review what we know. We know about uniform motion. Uniform motion is when your speed or velocity is constant. That means it's not changing. Acceleration is what we call when the speed is changing. So if the velocity is not constant, then it must be changing. That's the definition of acceleration. Acceleration is the rate of change in velocity and is called acceleration. This is non-uniform motion. The formula is really simple. Acceleration is equal to delta. That little triangle is a math symbol that means the change in speed or velocity divided by the change in time. So when you say the change in speed, we're looking at our final velocity, subtract our initial velocity, okay, divided by our time. So if you're reading an example and it says the change in velocity is this, you can use that symbol. If it tells you the final speed or final velocity and the initial velocity, we have to use this part of the formula. The units for acceleration, we use one of two things. The proper units is meters per second squared, but this is a very common unit because it makes the most sense to us. When we drive our cars, buses, bikes, the speedometer is always in kilometers per hour, and when we accelerate, we only speed up or slow down for a few seconds at a time. When we speed up, that's considered positive acceleration. When we slow down, that's negative acceleration or deceleration. So if you see a negative acceleration, it means someone is slowing down. If it's positive, we're going faster. Let's try a couple examples. So our first example here says a motorbike starting from rest. So we know VI is 0. Rest just means you're not moving yet. Undergoes uniform acceleration. All the acceleration formulas or questions we will do this year will all be uniform acceleration, so you don't have to worry about that word. Reaches a velocity of 21 meters per second north. So that's our final speed, or final velocity is 21 meters per second north in 8.4 seconds. So seconds is our time. And we're looking for acceleration. All right, so we know the final velocity, the initial velocity, so we can use this formula up top. So we have acceleration is equal to VF minus VI divided by T. Let's plug in what we know. VF is, got my little arrows, 21 minus 0 divided by our time, which is 8.4. And when we punch all that into our calculator, I have my calculator here, we get 2.5. That would be meters per second squared. And our direction was north, so it's still north. Let's try another example now. Let's try this one. So it says a cyclist is traveling initially at 14 meters per second south. So I know what my VI is. My VI is 14 meters per second south. Brakes smoothly at a rate of 3.5 meters per second squared. So meters per second squared, I know that's acceleration. And the direction was north. Now, when I look at my units, I have one is south and one is north, and that's a problem for me. I want my units to be the same. So to make them the same, I can simply just make this negative. So it'll be negative 3.5 meters per second squared south. And I know I'm slowing down. When I have a negative acceleration, it means I'm slowing down. And I come to rest. So I've actually slowed down till I stop. So VF is equal to 0. And it's asking me, how long did this take? I'm looking for T. All right, so our formula was A is equal to VF minus VI divided by T. I'm trying to get T all alone, but T is in the denominator. Whenever you're solving for something in the denominator, that's a problem. You need to get it out of the bottom. So the opposite of dividing by T would be to multiply by T. The T's cancel out, and I'm left with TA is equal to VF minus VI. All right, now I have t times a. I don't want t times a, I want just a. Sorry, I just want t, solving for t. So I'm going to divide both sides by a. The a's cancel out. And I'm left with t is equal to vf minus vi, all divided by a. All right, my final velocity was 0, minus my initial, which was 14, divided by my acceleration, which was negative 3.5. It's negative because I want the directions to be the same. When I put that into my calculator, I end up with negative divided by negative is a positive, so positive 4 seconds.